Alrighty, let the fun begin. There's no chance I'm making a video for all 4 pages at once. So let's maybe do 1 page at a time. We'll see how it goes. I don't really have a lot of juice left in my iPad, and I have spent way too much time digging around my house looking for a charger. So let's at least get part of this up and running. So it says to find the slope intercept form. Really important to read directions through these 2 points. So slope intercept form is y equals mx plus b. I am kind of getting to a place where I just use point slope as my start off spot, but I still need the slope. So I'm going to find the slope because I was given 2 points. I'm going to find it by doing y2 minus y1 over x2 minus x1. And I'm going to end up with a super user-friendly slope of -1. That's slick. And then it doesn't make a difference which point I pick, so I'm going to pick the one that's easier to work with because it doesn't have any negatives. So I'll use my point slope, y minus the y coordinate equals the slope times x minus the x coordinate. And then you're just 2 steps away from being done. You're going to distribute. Watch that turn into a +3. Be careful with that. And then I need to add 2. So I write my answer as a slope-intercept equation, just like I was asked to do. So just kind of watch those things as you're taking your test later. Find an equation of a line that passes through this point. So that's going to be my x and y coordinate. And then it's talking about the various types of slope. Keep in mind, horizontal has a slope that is 0. The equation is y equals, because a horizontal line only crosses the y-axis. And then the number is going to be the y coordinate of that point, or it's not going to go through the point. So horizontal is going to have to be y equals -3. Similar thinking, if it's vertical, keep in mind that your slope is undefined and that it would only cross the x-axis, so it's going to be x equals a number. But in this case, that number has to be a 4 in order to cross through that point. And there's never any math with horizontal and vertical lines, so you just have to kind of learn what to do in those scenarios. Okay, this says that it's parallel, so that's code language for same slope to the line blah, blah, blah. And then it says here to use point slope form. Okay, so I'm supposed to write my answer in point slope form. So paying attention to that. First thing I need to do is find the slope. So I have 2x minus 4y equals 6. And I need to get the slope. So I'm going to get it into slope-intercept form for that purpose. That's going to involve moving the 2x over by subtraction. And then dividing each piece by -4. But the only piece I really care about is this one. So that's telling me that the original line that they gave me has a slope of 1/2. Because the -2 over -4 will reduce to that. So if it's in point slope form, I'm not going to have to do any more math. I'm going to do y minus the y coordinate of the point. And I'm still in the same one. See how I'm on part C? So I'm still using this same point from up here. So y minus the y part would be y minus -3. So that'll turn into a plus. And then equals the slope, which I just found, and then times x minus the x coordinate from the point you're using. And so I just leave it like that. Okay, what does it tell me to do next? Read the instructions. Equation of the line going through this point with a slope of -2/3 in each form. Okay, once you get the first form, then you move from one form to the next. You don't keep coming back to the original information. So point slope form, and the actual equations are written right here for you. So if you don't know them, kind of get to know them. So here, point slope form, I actually know the slope and the point. So I simply take y minus the y coordinate, but minus the negative becomes positive again, equals the slope times x minus the x coordinate. So that's actually just my answer. I don't have to do any work. If you know a point and the slope, you never have to do any work for that one. Now I'm going to take that equation and get it into slope-intercept formula, and that always takes 2 steps. The first one is distributing, which is relatively unpleasant simply because there's a fraction. But, I mean, the year before calculus, at some point in our math career, we have to become more confident about our fraction use. So the negatives cancel when I distribute that, and it becomes 4/3. And then I'm going to subtract this 5 over, but 5, I'm going to write as 15/3, or think of it as 15/3, because these two are both numbers, and then I can put them together more easily. And you do want to write your answers as fractions, because we don't really use decimals as much as we use fractions in calc, because they're more exact. Fractions are exact. Decimals are like, oh, rounded off or repeating, and we need it to be as exact as possible. So the steps to go from here to here are always the same. Distribute your slope and then move that value that's with the y over, like we did with the 5. And then standard form is just sort of like unpleasant, and it's not super helpful, to be honest. So one thing I don't want is fraction coefficients. And the easiest way to clear the fractions in this is to triple this whole entire thing. If I do that, this will become 3y. This would become negative 2x, because 3 times 2 is 6, and on the bottom I'd have a 3. And then this one is going to become negative 11, because the top 3 and the bottom 3 cancel. So I cleared the fractions. Now I just need to have the x term out in front of the y term. So that's an easy peasy switch. I just add it to this side. So my final term, or excuse me, my final equation has the 2x plus the 3y equal to that negative 11 constant. And in this form, the constant is the only thing that can be to the right. Parallel, perpendicular, neither. You literally have done this since Algebra 1. I feel confident that you know that parallel means they have the same slope. Perpendicular is going to mean they're opposite reciprocals. So they have opposite signs and they're flipped over versions of each other. And neither, shockingly, means that neither of those things happened. So in order to do that, you do have to find the slope of each line. So here, I'm going to find the slope between these two. So I have y2 minus y1 over x2 minus x1. So that turns into a negative 2 over 5. My pen's pooping out on me here. And then when I find the slope of this second line, I'm going to have y2 minus y1 over x2 minus x1. So I end up with 5 over negative 2. So these are obviously not the same. They are reciprocals, meaning they've been flipped over, but they're not opposites. They're both negative. So it doesn't meet the criteria for perpendicular or for parallel, therefore it's neither. In these next two equations, I have to find the slope by changing the form of the line. So if we take the top one and find slope 1, we're going to be creating slope-intercept form. The first thing I'm going to do is subtract that 3x over to the other side and add it to the 7 that was already there. And then I'm going to go through and divide by negative 2. And the only thing I care about out of this entire thing is right here. So my first slope is positive 3/2 because the negatives cancel. My second slope, I'm going to kind of do the same thing. I'm going to start by getting the y part alone, which requires me to add the 6x over to the 10 side, and then divide each piece by 4. I don't care a lot about the equation. I only care about the slope, which is 6 over 4, but 6 over 4 can be reduced to 3 over 2. So now that I have the two slopes, I compare them, and I got 3 over 2 in both cases, so those lines would be parallel. All right, so we are already rocking the bottom of the front page. Look at us go. Oh, well, I spoke too soon because now I have to plug in fractions. That's not fun. Or, excuse me, decimals into fractions. Honors pre-calc. So my honors mentality is saying, okay, in part A, I am going to put a negative 3.9 here and in here. Now, will you have a calculator on the test? Yes. Will you be able to type that in one fell swoop so that you get out the proper answer? I have no idea. I like to play it safe. I'm not a risk taker. So if I do the top, I get 0.1. If I do the bottom in parentheses, I get a negative 0.1. And I didn't mean in the parentheses, it's in the absolute value bars. Excuse me. So I end up with 0.1 over 0.1, which is just a positive 1. That is not complicated. It is just picky little details because of the decimals and kind of the matching values of it. So round 2 in B, negative 4.1 goes in for X on the top as well as the bottom. The top becomes negative 0.1. The bottom becomes the absolute value of negative 0.1, but this stays negative and this turns positive. So my answer, since they're the same value, I'm still going to get a 1, but in this case it's negative because the negative on the top doesn't go away because the absolute value only applies to the bottom. Here I can see that the issue is going to be the squaring and making sure that I'm cautious about that. So for A, I'm plugging in negative 3.9. So you do have a graphing calculator, but if you ask your graphing calculator the wrong question, it will give you the wrong answer. You should know off the top of your head that negative 3.9 squared is going to become a positive because anything squared is positive. But then you want to know that it's going to get multiplied by that negative 2. Now, you have a calculator. So if you type this in with the proper notation and parentheses and such, it will give you the right answer. It knows PEMDAS. So watch for plugging in numbers, particularly negatives, use parentheses, and that way you just can't go wrong. That's what I got. And then in B, I am doing the same thing, but instead of a negative 3.9, I'm plugging in negative 4.1. So let's do that. I have my negative 2 out in front. Oops, sorry, I didn't copy that right. And then in parentheses, I've got my negative 4.1 parentheses squared. So it's only squaring the negative 4.1. And then I'm going to add 4. And I'm going to get this. So that, my friends, is the work and the answers and the concepts from that first page. No chance I'm going to get through all of these tonight, but let's see. I will actually do this next problem and then it kind of switches to piecewise. So I will stop the video here and then I'll create another video that picks up where I left off. So this is that difference quotient thing right here. This is the difference quotient, and that is going to be kind of our first dipping our toes in the water for calculus. So let's review this process. You saw it in the notes and you saw it in the practice problems and you're seeing it on the review and you're going to end up seeing it on your test. So we start off nice and easy, but again, you need to be cautious because this negative in the problem does not cancel this other negative. That's not how that works. PEMDAS is real and it doesn't go away after algebra. So that means this portion is going to get done first, and that will actually become positive because it's a negative squared, and then there'll be another negative waiting out front. So let's keep going. So this has a minus 3, and then in parentheses, I'm plugging in a negative 3. So there's all kinds of ways to be confused. If you did this like in your brain, this would actually turn out to be a negative 9. These would cancel out and would actually become a positive 9. And then this would have a plus 4. Now, again, you're going to have a calculator. So these will cancel and you'll just get 4. So just be cautious that you're either using your brain to catch mistakes and or you're using your calculator to help you with those, understanding that your calculator will only do it right if you put that negative you're plugging in inside of parentheses so it knows what to do. All right, so this f of x plus h will actually go here later. Remember how they are like steps towards the difference quotient? And we don't really have to do any math for this part because that's the original thing they gave us. So let's start with the f of x plus h. So I go to my function, and every place that there was an x, I have to put x plus h and do to it whatever was happening to that x. So if you're like, whoa, I'm confused, all I've done is put that x plus h they told me to plug in for the two x's in my original function. This part's easy. I'm going to be just distributing that. This part is the one that most people struggle with. When you're squaring that, you need to actually multiply it by itself, and that will require you to FOIL, which is just a thing that by now you should know how to do. So I go ahead and FOIL this, and it turns out to be the same thing every single time. But this one has a negative in the front. So I distribute that negative. I've so far only been working with this, so I have not added any other parts yet. So if I distribute my negative, I get negative x squared minus 2xh minus h squared, and then continuing on from up here, I get negative 3x minus 3h, and then my little caboose of a plus 4 hanging at the end. We talked about this in class and that there's kind of a good way. Oh, and actually that's my answer for that part. Well, let's see. See if there's anything that can cancel out of here. In this particular problem, nothing cancels, nothing combines. So the entire thing, there's no other x squareds. There's no other xh's or h squareds or plain x's or plain h's. Or constants. It really wants me to do that update. Alrighty, so now keep in mind that on this next problem, we just found this part, and this part is the original. So let's go back and do that. I don't have a ton of space, but I was gonna make it happen. So I'm gonna take what I had, which was this, literally copying it from immediately above where I'm writing, and didn't leave myself enough room. Super happy about that, because I'm ultimately gonna, I'm gonna cheat. It's not really cheating, it's using my resources. This was my answer. This was the x plus h, f of x plus h. So that I'm just gonna go after that and subtract the original, and the original was negative x squared minus 3x plus 4. So I'm just looking back up at the original function. Now, all of that is going to ultimately be over h. That's what I'm doing. The yellow part was my f of x plus h from part B. And then I'm subtracting the original. Keep in mind that this negative is going to make this into a plus x squared, a plus 3x, and a minus 4. All right. That's just from distributing. This is the time where everything should cancel except for terms that have h. So I'm going to look at the terms that I've got going now and see what's going on. So my first term out here is a negative x squared. It does not have an h, so I'm super happy to have a positive x squared later in my work that cancels out. The next term's a negative 2h, so that's okay. Minus h squared, that's okay because it has an h. This negative 3x is problematic, but it's okay because there's a positive 3x over here that cancels. The negative 3h is okay because it has an h, and then the positive 4 has to cancel with the negative 4. So at that point, I have a negative 2xh minus h squared minus 3h all over h. So I can pull an h out of there. When I do that, and I'm not going to actually draw it, mostly because I just ran out of space, but think about this. You're going to pull an H out of each of these, so basically cancel one out from each term. So if you divide this first part by H, you're going to be left with just negative 2x because that H will cancel out. If you then look at the middle terms, you have an H squared over H, so you still have one H left. And then if you look at the last one, you pull out an H, you'll be left with negative 3. So this is my answer to C, and it is known as my difference quotient, my baby step towards calculus. Then we're going to get into the piecewise functions and domains and range and all that good stuff. So let's stop here, and then that'll be kind of the first video of the series. And then I'll do one, excuse me, potentially 2 more to get through the rest of the review. At least this is a good start, and I look forward to seeing you. Bye, guys.